Welcome to Coach Atkins Math. Today we'll be talking about the applications of right triangles, which is a fancy way to say that we have word problems that deal with Pythagorean's theorem. So, looking at example 1, Susie headed due north from her house. Okay, so she headed north from her house, 2 miles, to the store. She also wanted to go to the shoe store. The shoe store is directly 3 miles east, which means I have a 90-degree angle from her house. If she wanted to go directly from the grocery store to the shoe store, how far would she have gone? Well, I think everyone can see we've got a right triangle here. We're looking for C, so I'm going to say 2 squared plus 3 squared equals C squared, or 4 plus 9 equals C squared, 13 equals C squared, or the square root of 13 equals C, which in this case is the most simplified answer. So we would say that the distance from the store to the shoe store would be the radical 13 miles, which is just under 4 miles. Well, let's look down at example number 2. If a 12-foot ladder was placed against a wall, so let's go ahead and create a wall of a building. Got a 12-foot ladder. It's placed against the wall so that the base of the ladder was 4 feet from the base of the wall. How high up the wall would it go? So now we're looking for B. So I would say 4 squared plus B squared equals C squared. Or 16 plus B squared equals 144. B squared would have to be 128. Take the square root of both sides. 128 can be broken down. So let's see what into. I'm going to say 128. I'm going to go ahead and split it up and say divide by 2. That gives me 64. So 64 just splits up into 8 and 8, so I have a pair. So I would say that B equals 8. Got a lonely 2, so I'm going to say radical 2. And that would be my answer as I'm looking forward. Now I'm leaving my answer in that term because I could type that in the calculator. And I could say 8 radical 2 in the calculator. And I could give you this decimal, 11.314 or 0.3137. Or I could say 11.3137005. But that's still a rounded number. And so it's not an exact answer. By leaving our answer as 8 radical 2 or 8 square roots of 2, I've given you an exact answer that you can turn around and use later, knowing that you still have an exact answer. It's really important that you have exact answers as you get further along in life, especially if you end up building a bridge someday. Example number 3. A telephone pole broke 4 feet from the bottom. Well, we know telephone poles sit in the ground, so I'm going to go ahead and create my 90-degree angle. We know that it went 4 feet up before it broke, so it's probably going to have a jagged edge and a jagged edge. Okay, so it's a telephone pole. If the top of the pole landed 3 feet from the base of the tree, how tall was the pole originally? So now I can find C by using my 3 and 4. So I'd say 3 squared plus 4 squared equals C squared. If you don't remember your Pythagorean triples from the last set of notes, you'll work through that. Otherwise, you can say that 5 equals C. Well, C is 5, and I know that that's important, but it doesn't ask me for how much of the pole broke off. It asked me for how tall the pole was originally. So to find out how tall the pole was originally, I'm going to say 5 plus 4. I know that the pole was originally 9 feet tall. And that right there would be my final answer. So be careful that you make sure and you go back and you look at what question did they really ask me. Looking on at example number 4. Steve is trying to tie a tent down so that it will not blow away. He attaches a rope from the top of the tent. So let's say I've got a tent. Looks something like this. And I know I'm an amazing drawer. You're just going to have to forgive me for that. Okay, got myself a tent. He's got a rope attached to the top of the tent. And he wants to attach it to the stake to the ground. If the tent is 5 foot tall, so the height of the tent is 5 feet, and he has a rope that is 12 foot long, how far away can he put the stake? So, in case you haven't ever been camping, if he puts the stake too close, it does no good because the tent's still going to fly around. So his goal is to get the stake as far away as he can to make this a taut rope or a tight rope so that he does not have that issue. We're going to go ahead, I'm going to redraw our triangle real quickly for you. We said this was 5, we said this was 12, and we are looking for this third side here. Again, if you remember your Pythagorean triples, you would say, oh, well, that's 5, 12, 13. But be very careful because in order for 5, 12, 13 to work, my hypotenuse must be the longest side, which would have to be 13. And I know the longest side is 12. So Pythagorean triples will not work here. 5 squared plus b squared would equal 12 squared, or 25 plus b squared equals 144, or b squared equals 119. Take the square root of both sides. Okay, so 119, we got to see if there's anything that goes into 119 very easily. Sitting here looking at it, little trick for you. If the last digit is divisible by 2, you can divide by 2. Not the case here. If the last number is, if I add all three together, 1 plus 1 is 2 plus 9 is 11. If 11 was divisible by 3, the number would be divisible by 3, but it's not. So to know if it's divisible by 4, I'm going to hide the back. I'm only going to look at the last 2 digits. If that was divisible by 4, I could use the number 4. It's not. So the number 5, if the last digit ends in a 5 or a 0, I could use the number 5. 6, well, if 2 and 3 don't work, 6 won't work. 7, let's try 7 real quickly, which at this point, I would suggest just typing it in. 119 divided by 7. There you go. So 119 splits up into 7 times 17. Well, those are both prime numbers. We can't do anything else with it. So we will just say that our answer here is b equals the radical of 119. Okay? So we know that the distance needs to be radical 119 feet away. Now, in certain circumstances, 119 is not going to help us. So just to help me get a feel, I'm going to go ahead and type it in and say 119 right here. So I would be looking at almost 11 feet. So that's good for me to see just because it helps me understand what I'm looking at. But for our answers right now, I'm going to ask that you leave all of your answers in radical form. Example number 5. Jerry wants to plant trees along a diagonal of the rectangular backyard. Let's go ahead and draw Jerry's backyard. It's a rectangle. His backyard is 35 feet by 20 feet. And he wants to plant a tree every 3 feet along the diagonal. About how many trees would he need? So the first thing we got to do is we got to figure out what the diagonal is. So I'm going to say 20 squared plus 35 squared equals c squared, our diagonal squared. Which now that these numbers are getting bigger, it's going to take a little bit more math. So I'm going to go ahead and put it in our calculator and say 20 squared plus 35 squared, 1625 would equal c squared. So we're going to take the square root of both sides. So right here, 1625 can be broken up. I know it can be broken up because I can see that right now, if I divide by 5, I've got at least one number that comes out. So I'm going to say 1625. I'm going to divide by 5. And I find 325, which means I can divide by 5 again, which gives me 65, which means I can divide by 5 again. It gives me 13. So, as I'm looking at this, I know I've got the square root of 5 times 5 is going to go on the outside, and 5 times 13 on the inside would equal C. Or 5 radical 65 would equal C. That would be my diagonal. Now, this is where having the radical doesn't help me, because I need to know if he plants a tree every 3 feet, how many trees do we need? Well, let's go ahead and type this in. Let's say 5 radical 65. Okay, so the diagonal is approximately 40.3 feet. So I want a tree every 3 feet, so I'm going to divide by 3. And that tells me I should have 13.4 trees. Unfortunately, I can't have a partial tree. So if we think about this, we've got 40 feet. So I'm going to put a tree down every 3 feet all the way across. Okay. If I've got 13.4 trees, well, I can't have 0.4 trees, so it asks approximately how many trees he needs, about how many trees. So I would go ahead and tell him he would need 13 to 14 trees, based on if he wants them a little bit wider than 3 feet apart or a little bit closer together than 3 feet apart. Thank you for watching Coach Eichner's Math. Hope you have a great